so we'll just go with, I'm Senior Application Engineer at Lyndex-Nikken, and Steve Linehan's our Product Manager across a few different product lines, but mostly rotary tables. And we both have quite a bit of machine shop time under our belts and sales time. We're going to discuss bridging the skills gap and a solution for today's shortage, today's labor shortage. We did a study in the National Association for Manufacturing did a study that showed 2.1 million manufacturing jobs going unfilled by 2030, which is a potential loss of potentially $1 trillion. They surveyed 800 US-based manufacturing facilities and their CEOs, and what they found was that this labor was one of their top concerns. The labor shortage is one of their top concerns. Now, this slide is showing that the retaining quality talent or quality employees is still at the top of our list. This was the second quarter of 2024. But what the article mentioned was that the rising healthcare costs and unfavorable business climate has actually grown over the last few years significantly. It was like a 20% increase on the rising healthcare. So it jumped up, from that mid 40% up to the 60%. So attracting and retaining employees is still top of the list, but the increased cost of healthcare is taking over as well. And that affects us more it also affects us because it's part of having our employees. And this is a list of the top 10 customer retail corporations in the US based on gross profit. And I felt like this slide applies because it's good to understand who our employees have as options to go work for. And some of the benefits they offer. On average, these top 10 companies are starting at $24 an hour. That's a national average, so I'm sure that if I surveyed California versus Florida, those numbers would look different. And something Steve and I were talking about today, I'm from Houston, Texas, and I still go into shops. I'd say 60% of our shops are still unair conditioned. And if you try to work you don't have to be in Houston to know that in the summertime machine shops get hot. But in Houston, you can pay your people less if they've committed to the industry and your shop is air conditioned. I used to live in San Antonio, and I was driving into Uvalde, which is like an hour and a half away, and they would bus their employees in from San Antonio, and they would work there because their shop was air conditioned. So I put that in there. It wasn't, my research did not show, hey, guess what, Amazon is air conditioned, or Lowe's or Home Depot is air conditioned, but I do know that it is something that our employees are experiencing. And but healthcare, matched 401k, education assistance, paid vacation, paid sick time, bonus structures. So as a machinist or as a manufacturing facility, these are the benefits that, it's not just $24 an hour. There's a lot of other benefits that the people we were trying to hire are being offered in other places. In fact, I don't know if any of y'all listen to Gary Vee at all on social media. He doesn't even, and we just had an employee take a job that there's unlimited vacation time. They just care that you're getting your job done. And that doesn't really work in our industry. I mean, how often can your employee take vacation and still get his parts loaded? It's kind of a hard one to be up against. And so in today's, as leaders, we can't afford to procrastinate understanding the changes that we need to make. I mean, it's the current environment, the future is telling us that we need to make these changes. And what we've got to understand is, what do we need to do to retain while bridging this gap? It's not an either or, like how do I retain or how do I cover the gap? We need to figure out how it works together. And some of these, these bullet points, I could read them to you, but they all parts of this corporate structure and the things that we're, closing the pay gap, workforce reskilling, the digital factory is how we're going to bridge that gap, bridge these gaps. So these are all things that we need to understand as leaders. And when we talk about lean manufacturing, I'm sure we've all heard this and have some kind of understanding of it, but lean manufacturing focuses on increasing efficiencies and decreasing waste. And, of course, Toyota made this popular back in the 40s and 50s. They started doing their own experimenting. In the 60s, they started making big changes across their manufacturing facilities. There are 8 categories of industrial waste identified in lean: defective parts, overproduction, wait time, non-utilization of talent, inventory excess, transportation, motion waste, and excessive processing. And this looks different from if you're an assembly plant, or if you're a production shop, or if you're a job shop. The 8 categories of waste still exist within your facility, but how we tackle it or how we solve this waste, it changes from facility to facility. So really the question is, does lean manufacturing work in a job shop environment? And does it mean that we have to scale down our workforce? If I implement lean, do I need fewer employees? This is kind of a yes, no, maybe. But while things are different from one manufacturing facility to the next, the processes of lean will have different effects. And so we have to keep, maybe we have to keep our minds open to the change. And change isn't easy. A lot of times there's cultural change that has to take place. And I was at an automation conference recently, and the culture of automation it's a big change. We have conversations with manufacturers. I'll have a CEO with his programmer next to him. We'll be talking about automation, and the programmer's like, "Oh, you're trying to get rid of me." And there's a lot of emotional connection to jobs, to job descriptions, to processes. And so we have to take, it's a slow step. It's more of a journey as we go into lean at whatever level that we enter lean. But the changes are possible, and we have to keep an open mind.
So these are 4 of the steps that we're going to discuss as we look at how we can convert our shops, how we can become more efficient. We have less people in our industry, so we really need to be able to make them more efficient. And how can we do that as shop owners? And the first thing we need to do is understand where we're at before we can implement the other processes, right? We have to gather some information and put together a plan in order to make our people more effective, right? We don't want to replace them. We actually want more people gathered in. We want to educate them up. So we need to find where we're at and what the starting point is before we can move on. So, spacebar. Oh, thanks. Okay. So data collection. Right now, if you watch any kind of major sports, analytics is a key part of everything that you find. Should I go for it on 4th and 1? Should I take a 3-point shot versus a 2-point shot? Data is very important for decision making. So if you're in a shop and you're not fully aware of what your machine times are and what you're doing, it's very difficult to make key changes. So we need to start gathering data, and what's that going to look like, right? We don't want it to be so cumbersome that it's overwhelming and then we push it to the side. Right, so in the process of doing this, we have several areas we need to understand in our shops, right? We have measuring productivity of employees, and then we have machine efficiencies. So in order to keep personnel, we need to define what they do. We need to give them objectives. You want to have them desire to stay in your facility. Right? Is your shop clean? Is it safe? Does it have latest technologies? Are you helping your employee do their job? Or are you making it a hindrance? Are you using old technology that makes them struggle? Right? If you're making your employees struggle, they're not going to be efficient. They're going to spend time frustrated doing tasks that can be very easily done with updated technology or education. right? So for employees, in order for them to be happy and want to stay, you need to give them objectives. You have to have a way to measure what they're doing and set goals for them, right? Key performance indicators, and that could be as simple as, hey, are you making your part count? Are you here in a timely manner? Is your machine running the times it should be? Or are you here on a Thursday, you're a little bit hungover, and you're turning the cycle, the feed rate down to 70%, cheating the system because you don't feel good that day, right? So we need to measure and keep people accountable for our own sake, but also for their growth and development, right? If you're working for a company and you don't know where you stand or how you can get a raise or how you could move forward and what the objectives are, it becomes very difficult to stay there. And on the machine side, how effective are your machines? In a perfect world, if you're running a 40-hour week, you would believe the vertical machining center or horizontal you purchase would be running 40 hours cutting chips, right? That's a perfect world, but we know that's not true. So in your shop, do you know what that looks like? Do you know when the machine's cutting chips or it's idle because people are setting up jobs? What does that look like? And if you're not monitoring that, then it's very difficult for you to decide, do I purchase new equipment? Am I keeping up with jobs? Am I inefficient because the operator is slow? So those are some of the things that we need to monitor and kind of separate the two to understand the whole picture. So data collection. What does that look like? Is that a difficult thing? Is it expensive? Right? What's available on the market? There's softwares, there's other products where you clip onto a power line and it monitors spikes in power consumption in the machine. This is a product that uses data collection through the light tower. Very effective. You take the machine's light tower off, mount this on, it monitors cycle start, cycle finish, and idle time. And what that's going to tell us is, and we can map out our machine shop, I can put as many of these in. Machine number 1, I can assign it to an employee. I can monitor a job time and job cycle. So I can be very specific as to, hey, machine number 1 is Bill, he's running this job. Boy, this job is running very slow today. What's going on? Is he having programming issues? Is it part slipping? Is it bad parts, bad cutting tools? So I can monitor that specific machine. And the end goal is to send out a data report of machine utilization, right? So a certain percent, my machine is up and running, I'm making good parts. A little time is red, that means the cycles have stopped. They're sitting dormant until someone starts them. And then the yellow segment might be, I think up here it's 27% of the time the machine is idle. So if that's the case, what's it doing in the idle time? And if you don't know what it's doing in the idle time, this is a way to track that. And this is a very simple way to do it by just replacing your standard light tower on your machine. They hook up Bluetooth and provide you this data. And then you could spit it out into Excel and other formats. So then you could just monitor it. You could go and review your employees weekly. You can watch it in real time as the machines are running and not running and what condition they're in. So if you're in your office and you see idle, 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 I hope it's lunchtime and they don't have to run machines at lunch, right? So it's a very good way to keep an eye on what's going on in your shop and help yourself be productive and efficient, excuse me. So we've collected our data, right? And now we know that perhaps setup time is very, very expensive and it's what your weak spot is, right? So now we're gonna implement some of those findings and figure out how to fix the problems. What are the bottlenecks? Is it just employees not being productive? Is it setup time? Is it issues? So we've got a good piece of data and now we can work from that data. So if it's work holding and job changeover, if you're a job shop and you're like, oh, we're changing jobs multiple times a week It's very difficult to stay efficient. There are products in the market now that help changeover become very fluid and simple. It allows you to become very agile. And also it's worker friendly. So we're gonna look at a few examples. So in the old days, when Stephen and I worked in the shop, you had Kurt Weiss's. I programmed at my control. I would literally program in G-code into my control the whole time. So that machine would sit for hours while I sat at the control programming it, right? So now there are systems like this. This is a 0-point system. What it would allow me to do is easily, in seconds, release work holding from your machine platform and change it out, right? The days are gone of a 15/16 wrench, unbolting my vices, sliding them off, stoning the table, restoning vices, changing my fixtures out. These systems are designed to fire air to them, lift your work holding off, place a new one on. The accuracy of systems like this are within 1/10, 2/10. So your home positions, your origins for your work should be known. You could go right to work. You'd start cycle, off you go. So is it available just in a vertical platform? It can be done in 5 axes. It can be done in horizontals. And this is some of the examples of what it looks like. 5-axis machines, complicated parts, you need to get into reach into tight spots. You know, the traditional way of clamping parts becomes cumbersome and ineffective. You're stacking on top and you're trying to reach around to get into tight spots. So with the 0-point system, you can easily take pneumatic vices on and off, change work holding positions, and always have that location known. So it's very simple and easy. Here's a few of the examples of prefabricated products that can be used. So if I need to boost a part up, I have a riser platform. I have a rail vise system. So I have a variety of off-the-shelf items, so I'm not making fixtures. When I worked, a lot of the jobs we did, hey, let's sit down, let's design a fixture, get some steel, start making clamp, drill, tap, and create fixtures for each job. On the market with these type of systems, they're very easy to use and find different systems that are more functional and helpful. Here's another example where with these 0-point systems, I don't only have to put vices or work holding, I can machine, like dovetail is very popular now, dovetail vices. With this system, I can machine pull stud holes, drill and tap, put the pull studs in, hold the part, machine it, flip it over, and deck it, and I'm done. So I can do more complex parts more easily. Here's a few more examples. I could do rail vices, I could hold multiple parts. I could grab long, awkward parts. So this is not only quick and agile for your shop, but it also for your programmer and for your setup guys and the operators. Right? It's all about, you know, nowadays, whether we like it or not, quality of life is a big issue. Right? You know, I don't have to work here. I can go work at McDonald's for $15 an hour, right? And I won't come home with cuts and scratches and not lifting tons of parts and heavy stuff. So systems like this, for an operator, it's very convenient, easy, and it makes work more palatable. And then here's a couple more examples. This is the riser. So I could directly mount a part to the riser, or I can mount a vise to the riser. And in seconds, I can just hit air, take it off, and place something else on. And have known locations, known origins stored in my machine. So these are ways that we can help make our people more efficient and effective, because trying to reset a 5-axis machine with different fixtures, trying to find the center points can be very difficult and time consuming. And this is vertical applications. So I can grab long parts, short parts. I can grab a vise with a vise. I can adjust these vices. So it's all about flexibility and ease of use, right? This is the type of product and a technology that can help you get away from manual fixtures. And here's some of this stuff. If you're not familiar, you can put this on rotary tables. It's good for me. I'm the rotary table product manager. I like this slide. This does me good. So, but this is, again, flexibility, production, right? If I can load all these sides with parts, I can hit a cycle start, and then my employee has time. So in my day, my boss would pull the belt sander up and a drill press, and then I would take parts off the fixture, I'd deburr them, and then chamfer them, and then put them in the box. Nowadays, if there's a shortage of workers, I can load a system like this. I can have a secondary machine nearby, where if we're efficient and our work holding and we're building time, right? By being more efficient, we're building more time for them to be free. They can easily run 2 machines, perhaps 3 machines. And this would be close to getting automated, right? So we could do this in a manual way and then automate it, right? So the job here is to find ways for people to do more with less.
So what challenges do you generally see in data collection process?
It's how it's monitored. A lot of people just check cycle start and cycle finish, right? And how does that look? You know, if you're not gathering all the data of the machine, then it's garbage in, garbage out, right? There's a variety of different systems. There's softwares. It's all generated by price point. What's your investment? What are you willing to invest? You know, if you're a small shop and you don't have a lot of money, there are sophisticated systems that after software and readers on each machine and gather data. It's all about what you can afford to do. There are simple ways, and then there's more difficult, more sophisticated ways. So it's all sizable, so to speak.
So the data maturity perspective, where do you see the industry at? Is it in 1 to 10 scale, we are at 7, 8, maybe below 5? Because I think that you said, I think the garbage in, garbage out, right? I think that if the data is not collected, mature, cannot be loaded for leads and busting, it's going to be, you can bring a number of tools. It's going to be really, really hard to automate this stuff. So as an industry, if we move maturity curve on this.
I think we are. I think as an industry, with work holding, Stephen, what did we find? We were looking at as part of our talk, it's idle time. So as an industry, our idle time of a machine for changeover and setup was what?
Yeah, in 2010, Top Shops reported average part setup from one part to the other was 2.5 hours. And then in 2014, the report showed 38 minutes. And so these Top Shops, I don't know if you're familiar with Top Shops, they give surveys to a lot of these top shops and they analyze that data. So it's nice to see that in that four-year span that they were looking at their data and becoming more efficient at changeover. But I think that some of the challenges that we have in our industry, one, we're slow to adapt or adopt new technology, just as a whole. I mean, expanding if you have a fan at control and you want to expand the memory from, was it like 64 gigs to 1 gig, it's like $6,000, and your sales guy is telling you not to do it because it doesn't really know what to do with the memory anyway. And so I think that we're slow to adopt technology. And then when the new technology does come to us, it's proprietary. And so I can't, while I can put it on my machine, it doesn't talk to any of my other software, right? So then you have to pick an ERP system, and that ERP system needs to be complete. And then they charge for that, right? So the data collection challenges are cost, proprietary, and then our ability to want to adopt it. That's my opinion.
Well, through my career, over 30 years in the industry, there's a lot of companies that this is how we've always done it. We don't have to change. Look, man, hey, this will do it in half the time. That's how we always done. You've never machined this part. Okay. But that kind of mentality will put you out of business, right? What you were doing 25 years ago versus today, it's night and day. So as machines advance, there's some of that monitoring software built into them. There's a lot of different add-ons. It's you as the owner or the managers to weed through some of that data and find out for your building what works, how it works, and to find out what you want to measure and how you're measuring it. So here, so this technology, this lean work holding can be used in verticals, horizontals. So in a shop, I'm not pigeonholed into one thing. I can't just use the platform here. I can use it on 5-axis machines. I can use it on vertical machines. I can use it on horizontal machines. I can use this kind of technology on CMM. So as a part goes through your system, there's these lean practices and technology that can help streamline all your processes, right? Which is at the end of the day going to free up time for your employees to do other things, and you get more mileage out of them. But then also make their life more comfortable because you're providing technology and education. So, and here's the CMM and measuring systems. So, oh my goodness, okay. So this is an example of the clamping structures. So this just keeps going to show you more and more of the versatility. So I can clamp directly on sophisticated parts where you couldn't normally grab this. How would you clamp this? You'd have to build a very expensive fixture to hold these. Now by using just a threaded rod into one of the clamping units, I can put very sophisticated parts on here.
We got put in the mode.
Oh, that I must have. Okay, I think it stopped. Sorry, I put it in a mode. My apologies.
All right, I think we're good now. So I think another thing too, one more thing on that technology or the data collection. How many people in here have a machine with FANUC controls on it? Probably almost everybody. Less than I thought. A lot less than I thought. But FANUC has a lot of data collection built into their servo motors, into their controls, and our machine tool dealers, I mean, it has, when your machine tool dealer comes, does he tell you that your machine can let you know if your servos are getting hotter than normal, your servo motors are getting hotter than normal, or are experiencing more resistance on them while working? So FANUC has a lot of technology built into their controls, and then there's not a lot of education letting us know that that technology is there as well. So there's just a lot of education, a lot of choices to be made in the data collection. So we've talked about implementing lean processes to help remove some waste from our manufacturing processes. Our vision for automation at Lyndex-Nikken is to automate your lean processes. And so we have two versions of automation that we've identified. One is an unmanned machining automation process, and so maybe your part quantity is lower. So instead of having enough to cover 16 hours of production, you're going to have enough to maybe cover 8 hours, but that gives your guy more freedom. Maybe it covers 6 hours and gives your operator more freedom to go do other things. The other version of automation would be lights out. So now we're covering multiple shifts. No one's there. The lights are out. It's unmanned. And we do this, again, by automating our lean manufacturing process, the lean manufacturing processes that you've already started to implement. And this, you know, it goes across your entire shop, whether it's mills or lathes. I mean, lathes are nice because automation is easy. You can bar feed. We have parts catchers, all those things. But sometimes, you know, you need more automation at a lathe. So some advantages of unmanned machining would be reduced labor cost, better quality and reliability, increased throughput, better consistencies. Systems that would, these are some systems that we would consider unmanned, and so you don't have that part density to carry you throughout multiple shifts, but we have simplicity for setup. We have area scanners for safety. Other options have a little bit more part density, but still maybe the parts cycle time doesn't get us through multiple shifts. This style has a rack that you can load parts on one rack and then just switch the racks out quickly. So typically your unmanned solutions, they aren't as difficult to integrate as your lights out stuff because you're not monitoring as much on the machines. So as we move into lights out machining, it takes a lot more. I wish Fanuc made a machine that looked this cool. But it takes a lot more technology, a lot more integration. And while we might think that an unmanned or lights out machining it looks this complex, right? Or maybe in your job shop scenario, you feel like you don't have enough part density or enough quantity on your parts to warrant or to give you an ROI on automation. And so typically when I think automation, I do think of the automotive space. This is obviously some kind of welding or sheet metal process. Probably not something that anyone in this room does, but we've all seen shops with mills dedicated to Ford calipers. Maybe we haven't seen them, but we know they exist. And that's not quite what it takes. What our focus is, again, when we look at lean, is high mix, low volume. And so we need something that is easy to set up, doesn't cost an arm and a leg, and our operators can quickly change from job to job. This is a pallet-based system, nice little industrial robot on it. Has a user interface that's very simple to use, just a few questions to get you up and running. And when we look at the ROI side of things, 20-minute cycle times, is that fairly normal for our mills? So, a 20-minute cycle time, 72 parts, you could look at 24 hours of unattended runtime on this system. Maybe your parts are a little bit bigger, so then we're at the 16-hour mark. So the ROI for high mix, low volume, it exists with the correct machine tending automation platform. We can also get into more complex CNC or machine tending systems. This system will load raw parts, then it'll switch out your top tooling and run vice work. So your op 10 can be put in pretty quick and pretty easy. Then it can switch itself out for that op 20 for the vice work. So there's a lot of systems out there today that will help us take these lean manufacturing processes and get them automated without requiring the expense of robotic engineers or developing a system specifically for your shop and your processes. And that's kind of where the journey comes. The journey is we collect our data, we look at our manufacturing processes, identify some waste, and then implement lean processes to reduce that waste, and then we'll finally take those lean processes and automate them. I don't want to show you this last slide. I did not put the balloons on it.
Well, we thank you so much
yes.
for participating and coming to see this presentation. We hope you take something away from it. We greatly appreciate the opportunity. So thank you very much.